So our first module will be physical science for the quarter one. It is all about formation of heavy elements. This module will walk you through the beginning of everything. It focuses on how some elements known today were formed, same as when stars were born right after the universe existed. You will be provided with activities such as filling out graphic organizer, reading storyboard and illustrations, which make you remember the lesson. Make sure to answer first the pretest before going through this module, and the post-test at the end of the module. The module consists of Lesson 1, Stellar Nucleosynthesis, Rise of the Stars. After going through this module, you are expected to explain stellar nucleosynthesis, describe the different stages of life cycle of stars, cite the different heavy elements formed in each stages of star cycle, and describe how heavier elements form during stellar nucleosynthesis and evolution. Have you also wondered what stars are made of? What keeps them shining so bright? Are there also stars that do not spark? You might also be asking the same questions ever since you were little, that until now you still seek answers for. Well, this module will help you understand some of the important concepts about stars. Are you ready? Let's go! But before we start the lesson, I want to check what you already know about the lesson. I want you to answer what I know on page 2 and 3 of your module. I will give you 10 minutes to answer the 15 questions. For Lesson 1, Stellar Nucleosynthesis, the Rise of the Stars. The world where we live today is just a small part of our universe. In your previous years, you have learned about different theories of the origin of the universe that eventually led to the formation of galaxies, solar system, and other heavenly bodies. This lesson will focus on one of those wonderful things present in outer space, the stars. Although stars are millions of light years away from us, we can still see them twinkling in the night sky. Let's find out how they emit light and what keeps them shining for a long time. What comes to your mind when you hear the word Big Bang? Scientists believe that the formation of the universe began through the explosion of a primordial atom which happened 13 billion years ago. It is known as the Big Bang. It became a theory that also explains the continuous expansion of the universe. Right after Big Bang, protons and neutrons combined together and formed light elements, hydrogen and helium, in the process of Big Bang nucleosynthesis. Other light elements such as lithium and beryllium were also formed during this process. Stellar nucleosynthesis. The word stellar means star, and the formation of elements in the center of the star is called stellar nucleosynthesis. Carl Sagan said that we are made of the star stuff. What did he mean by that? If we know how some important heavy elements were formed, same as stars, that may be a clue. I want you to answer what's new on page 6. Label the sequence of star cycle. Use the hints and clues found on page 7. Were you able to label all the stages of the star? Review the hints and clues in the previous activity. You will notice that following the sequence will reveal what happens in each stage of the star. I want you to answer, what is it on page 8? I want you to look at the diagram. This will explain how stars are formed into different stages because of nuclear fusion among heavy elements. So what is nuclear fusion? Nuclear fusion is the combination of nuclei to form heavier one. So the diagram shows the proton-proton chain reaction in main sequence star. So this is the process by which average star gets their energy and convert hydrogen into helium. It starts with proton and neutron fused together to form Deuterium. When one proton collides with deuterium, helium-3 is found. Two helium-3 collided will form helium-4. So case is different in massive star or star 8 times larger than solar mass. They undergo CNO cycle or the carbon, nitrogen, oxygen cycle to convert hydrogen into helium. You can see at the right how carbon-12 fuse with proton and form nitrogen-13. Nitrogen-13 undergoes beta decay to form carbon-13. Carbon-13 captures proton and nitrogen-14 is formed. Nitrogen-14 captures proton and oxygen-15 is produced. Oxygen-15 undergoes beta decay and produces nitrogen-15. Nitrogen-15 fused with proton gives off helium and ends up with carbon-12. Then the process repeats again. Tri-alpha process happens in red giant star once they leave the stage of main sequence star. This is how 3 helium-4 are converted into carbon. The triple A process begins when two helium nuclei fuse to form an unstable beryllium nucleus. If this nucleus collides with another helium nucleus before it breaks apart, the two will fuse to form a nucleus of carbon-12. The energy released is carried off both by the motion of the carbon nucleus and a gamma ray. A star accumulates more mass and continues to grow into red supergiant. Alpha particle fusion happens at its core and creates more heavy elements until iron. This is known as the alpha ladder process. How do elements heavier than iron form? As the energy at the core of the star decreases, nuclear fusion cannot produce elements higher than iron. Different pathways needed for heavier elements to be formed. Neutron capture. A neutron is added to a seed nucleus. Neutron capture can be slow or rapid. S process or slow process happen when there is a slow rate of capturing neutron while there is a faster rate of radioactive decay, hence increasing the proton by 1. While R process or rapid process means that there is a faster rate of capturing neutron before it undergoes radioactive decay. Thus, more neutrons can be combined in the nucleus. This is what happens in a supernova forming heavier elements than iron, with a process known as supernova nucleosynthesis. The explosion of star or supernova is believed to be the source of other elements heavier than iron. During the explosion, these heavy elements are dispersed into the space. Aside from gases, hydrogen and helium space, other evidence of star formation is the energy emitted during nuclear reaction. It is also the energy emitted by different forms of radiation such as UV, infrared, X-ray, radio wave, and microwave. Do you have any question? Okay, so let's move on. So I want you to answer page 12 of your module, what's more, match the terms in column A with its description in column B. So I want you also to answer what I have learned on page 13. Read the paragraph, then fill in the blanks with the correct word or words. Now that you have learned how stars are formed and evolve from one stage to another and its connection with heavy elements from carbon through iron, there are many processes that stars have to undergo before they evolve from one stage to another. For your next task, you will write a story which relates the events of your life from past, present, and future to the life cycle of a star. Use also those elements which could symbolize something or anything in your story. So I want you to write it on your big notebook. So it will be graded based on the rubrics on page 14. And for assessment, I want you to answer page 15 and 16 of your module. It is a multiple choice. Choose the letter of the best answer. Write the chosen letter on your big notebook. Last but not the least, I want you to answer additional activities. On this activity, you will see a star with the topic written on its center. Fill out the parts of the star with all the concepts you have learned in this module. To check if your answers on the previous activities are correct, you can turn your module on page 18, Answer Key. Congratulations, you have completed Module 1.